So I guess the way I look at it is that whether you think, humans are to cause into are the cause of global warming because of our burning of fossil fuels, and we're adding more carbon dioxide in the Earth's atmosphere, and it's a greenhouse gas, and that's why we have global warming. Or, whether you say, well, the Earth has historically gone through cooling and warming cycles, since way back when, we know that. I think it's hard to avoid the fact that we are right now experiencing global warming, and so whichever way you come down on it, we are definitely, I think, the surface temperatures. There's enough evidence to suggest that for whatever reason, Mother Nature or man-made, temperatures are rising. Now, I try to avoid the politics because I'm not a very good debater, but I just think that the data is there to say that the surface temperatures are warming. And so one of the consequences of surface temperatures rising is that the sea levels will rise. And when we say, well, sea levels will rise, and it's due to two factors with increasing surface temperatures. One is that those large amounts of water tied up at the poles or upper latitudes in ices, either glaciers or ice sheets, that is melting and becoming part of the active hydrological cycle. And the other is just basically, if you take any water in these large bodies of water, and if you heat that water up, like in our oceans, it's going to expand. It's going to stay a liquid, and some of it will stay a liquid and it'll just get larger. So both of those reasons make our sea levels rise. And so what you're looking at here is actually data that was taken by satellites to ultimately track the sea level changes in generally sea levels. So it looks like these dots each dot represents a 60-day average. Now, to me, it's hard to come up with a 60-day average for the general change in sea levels worldwide, but that's what they're doing here. And notice that there is definitely scatter, so the sea levels go up and down and up and down, and this is year from 1995 to 2005, so over a 10-year period of time. But throughout the world, global sea levels are rising. So notice they go up and down, but the trend represented here with a red line, the trend is increasing. And these in terms of millimeters, our sea levels are rising. And some people are getting hit harder than other people with regard to rising sea levels. So when your sea levels rise, depending upon what your coast is like, you may be in trouble or you may not be. This kind of gradual slope here will play havoc. So this is like our east coast, where you can kind of see we have a gradual shoreline, and when the sea levels rise, for instance, in the Atlantic Ocean, then we're going to be in trouble. If you compare that to our west coast, where we have the Pacific Ocean, we kind of have a drop-off. So with regard to the coastline, and as it meets the Pacific Ocean, so if the sea levels rise there, we're not in so much of a trouble. So it kind of depends on that. Now, regardless of if you're on our east coast in the United States or on our west coast of the United States, we know that coastal regions are highly populated, and that is due just to historically, it's easy to transport things if you live on the coast and all that. So this has consequences for having to relocate large numbers of people as the sea levels rise. Another kind of snapshot at what's happening to another proof, I guess I should say, that surface temperatures are generally warming is to look at the NP stands for the North Pole, and you can kind of see the ices. Where is my thing? NP's the North Pole. There's Santa Claus, and you can kind of see the ice sheet in 1979 to 2000. It used to be kind of out like here, 05 minimum, 07 minimum, So you can kind of see that it's less and less. The Arctic, I guess I should say the Arctic sea level is what they're showing there. And so to kind of quantify that and show you the decrease in the Arctic Sea from 78 to 2008, the area. So I don't know. This again is looking at the Arctic, and this reminds me of, remember we talked about a positive feedback mechanism to warming the oceans, and it ultimately decreases the ices and all that, and it basically adds more to the warming effect. We kind of have a similar thing going on here. So for instance, as surface temperatures warm, what that's going to do is some of that permafrost we're going to talk about when we talk about climates in the next chapter. But the permafrost will generally thaw, and kind of like when ices melt and snow melt, basically the thawed out permafrost, the regular grass now, will absorb more radiation and be less reflective. So as it absorbs more radiation, it's going to go ahead and warm. So this is an example of a positive feedback mechanism. So if you initiate global warming in this area, it can spiral and keep that global warming going. So this might be kind of small for you to see on this slide, but I just refer you to chapter 14, table 1. And this isn't like the feel-good table of this textbook. So this basically says with global warming, and notice you're going to see it kind of quantifies. For instance, this is virtually certain, which the probability is greater than 99% of these impacts. Virtually certain here, very likely, likely, and likely. And the likely scenarios are there's a 67 to 90% probability that that will be the case. So I'll just kind of let you read through these, but these are not happy things with global warming. Again, we know that the Earth has gone through periods of ice ages and warm periods. So, but I don't think our greenhouse gas emissions have helped any. So this is kind of this is table 14.2, and it's similar, but it kind of breaks it down by region. So for instance, just down here we have North America, and it says that kind of gives us a scenario of things to expect. Polar regions, notice that everybody gets some effect. Smaller islands, Africa, Asia, Australia, New Zealand, Europe, and then last, Latin America. So again, I just would encourage you to take a look at these expected changes that these regions will have because of changes in climate, specifically global warming.